This is a super quick and easy demonstration of how EMC ViPR, and specifically the EMC ViPR controller, can be used to automate a whole slew of storage tasks using, in this particular case, the vCloud Suite's Automation Center. So what we've got here is the ViPR controller, and we've had a series of physical assets. Here you can see both a NetApp FAS platform and previous generation VNX 5000. We've created a virtual array. A virtual array is a logical construct with virtual pools. These are abstracted pools that are using the underlying storage, in this case either the NetApp FAS platform or the VNX platform. In there we've created a block pool and a file pool, and these are being used to deliver block or file services. So you can again see this concept of abstraction. Now in this particular case you can see that those virtual pools, for example, here are sitting on top of the VNX, and likewise you can drill down and see where they sit on top of the NetApp FAS platform. Now what we're going to do is we're going to actually go through and do some provisioning. So for example, we'll create a volume and a data store that's going to get presented up to the vSphere cluster. And we're going to go in and we're going to create an NFS-based data store. Now again, one thing that's really cool about this, that's important to note, is that we've abstracted out where the actual storage is going to be provisioned from. And this could be an environment that has a whole slew of different storage devices with different underlying capabilities. But now that we've done that basic step, all of the subsequent tasks can be completely automated via vCenter Orchestrator and via the vCloud Automation Center, or vCAC toolset. So for example, here we can have a workflow that will go through and actually do VMFS data store provisioning or NFS data store provisioning and automate various tasks. The other thing that we can do is, if you log into vCloud Automation Center, you can see, for example, a series of provisioning tasks and requests we could do. So for example, there's a series of inbound requests to request multiple logical virtual machines. Now, when this is potentially the front-end portal where the user is coming in and saying, hey, look, I need to get a development copy of a series of things, and you'll notice that they can say, hey, where do I want to put it? I want to put it on this particular data store, and I'm going to require it to sit on a given type of storage. And off that goes, and that provisioning task can go down, and it'll automatically pool from those abstracted pools of storage the one that could fit the best possible storage fit. Now again, you could do this actually without EMC ViPR in the picture here if you wanted to use just vSphere using VASA and the vCloud Automation Center, as long as you use the VASA providers for EMC, for NetApp, or for all of the different potential arrays that you might have in your environment. It's very unusual for a customer to be heterogeneous. Of course, even if you're just using vSphere, EMC's ViPR controller will abstract all of those and only requires one underlying VASA provider, only one underlying required API. And there's one additional thing, which isn't going to be in this demonstration, but in another one, which is you could also use the same ViPR APIs to work with OpenStack or to work with Hyper-V. Now here what we're doing as well is we're making another multi-machine request, which is to basically go off and create a production version of an app. And in this case, we're going to say that we're going to use it on a different type of storage, something with different characteristics. We're going to put it on production. We'll put it on the EMC virtual pool of storage. But remember, it's not immediately apparent to this layer of abstraction whether it's on EMC or NetApp, and frankly, you probably don't want it to be. You want to keep it very simple. So off those machine requests are now churning. So here we're looking at this second request. Again, you could make it so that it happened automatically, but we've made it so we're going to make an approval or a denial of this individual request from the end user. And off it goes. We've approved the request. The provisioning task is complete. If we log back into the user portal, the user basically says, hey, my machines are now up and running, both development and prod. By the way, what's interesting is look at the UI. To people who are using the vCloud hybrid service from VMware, this will look pretty familiar. It's not dissimilar from the user experience that you get when you're using the vCloud hybrid service. So all that stuff happened automatically, and here if we go back in, you could see in the vSphere client those individual VMs are now provisioned, and they're running on the underlying data stores where they were all placed completely automatically. In this case, the non-prod is sitting on NetApp, and the prod is sitting on top of EMC data stores. And one thing that's interesting is if you go and you look inside the ViPR UI, you can see actually the entire topology, but you can also see the series of actions which were completely automated. So for example, here we're going to go into resources. If you go and you take a look, we've got an underlying logical volume. That logical volume is sitting on these particular underlying systems that are presented out to these hosts. And likewise, this NFS-based data store is presented out to these hosts. So again, you can see all of that stuff was done completely automated in a hands-off way, which is really cool.